Hello. Looking at some GCSE physics questions on force, mass and acceleration. 1. If an object is at rest or moving at steady velocity, what can you say about the forces acting on it? We can say that the forces are balanced. 2. A free fall parachutist falls at his terminal velocity of 50 meters per second. If his mass is 85 kilograms, A. What is the pull of the Earth on him in newtons? Force equals weight equals mg equals 85 times 9.81 equals 834 newtons. B. What is the force of resistance acting on him? Explain your answer. So the force of drag is the same as the weight, 834 newtons. This is because the resultant force is 0. So they have to be acting opposite to each other. So the vector of force is the negative of the vector of weight. What is meant by the word weight? It is the gravitational force acting on an object. If you are in a car that accelerates suddenly, what happens to you and why? You resist the change in motion due to inertia. So you go back in the seat as the car moves forward. Question 5. What force gives a mass of 3 kilograms and acceleration of 4 meters per second squared? Resultant force equals ma. 3 times 4, 12 newtons. M being 3, A being 4. A force of 50 newtons is applied to a mass of 10 kg. What is its acceleration? Acceleration is the resultant force divided by the mass. 50 divided by 10, 5 meters per second squared. 7. A 16 Newton force is just sufficient to keep a trolley moving at a steady velocity. If the velocity has a mass of 4 kg, what is the force of friction on the trolley? Force of friction on the trolley? Well, because it's moving at a steady speed, then the resultant force is 0. Therefore, there must be a 16 Newton force in the opposite direction to the motion, which is the friction. B. What is the acceleration of the trolley if the force is doubled, the frictional force remaining the same? So therefore, we've got 32 newtons forwards, but the friction is 16. So 32 minus 16 is 16. So the resultant force is 16 divided by the mass of 4 gives 4 newtons, 4 meters per second squared rather, for the acceleration. 8. A girl of mass 35 kg sits on a stool. What is the reaction of the stool on her? Well, the reaction force is equal to the weight because there's no movement, which is equal to mg, which is equal to 35 times 9.81 equals 343 newtons. 9. Thrust of a certain rocket engine is 100,000 newtons. If the mass of the rocket at takeoff is 5,000 kg, what is the initial acceleration of the rocket? So the acceleration is the resultant force, so it's 100,000 upwards and 49,050 downwards, because we work out what the weight here of the, you see the weight is the mass times the gravity, so that's the weight of the rocket. So the thrust minus the weight, this is the resultant force here, divided by the mass gives 10.2 meters per second squared. Question 10. A block of mass 2.0 kg is given a push to start it moving along a bench. Once it's moving, a force of 4 newtons is just enough to keep it moving at a constant velocity. So therefore, the resultant force is 0 because it's a constant velocity. Whenever you see that, which means that resultant force is 0. What is the acceleration of the block as pulled as increased from 4 newtons to 16 newtons? So now the resultant force is now 16 minus 4, because 4 is backwards, because for the resultant force to be 0 in the first place it had to be 4 backwards, i.e. the friction needed to be 4. So 4 minus 4 would be 0, but in this case the forwards force has been increased to 16, so it's 16 minus 4 rather than 4 minus 4. So 16 minus 4 is 12, 12 divided by 2 is 6 meters per second squared. 11. A car travels along a road. The thrust of the car engine is 1200 newtons. The wind and road resistance gives a drag force of 400 newtons. If the mass of the car is 1,000 kilograms, what is the acceleration of the car? Force divided by mass, 1200 minus 400 divided by 1000. This is the resultant force, 1200 minus 400, so it gives 0.8 meters per second squared. 12. A force acts on a moving rubber ball. Name 3 changes that could happen to the ball because of the force. So it could start to move. So it could, number 1, it could change its velocity. So it could change its speed. It could change its direction. So speed, or change its direction, or it could change its shape. Number 13. Explain whether the mass and or the weight of an SUV will change, that's a type of vehicle, will change as it travels from the North Pole to the equator. The mass will remain constant. The weight is about 0.5% more at the poles. 14. A girl and boy are pulling in opposite directions on a rope. The forces acting on the rope are shown in the diagram. A. Is there a single force that has the same effect as the 2 forces shown? Yes, there is. The resultant force is the difference between them, 50 newtons towards the left. B. Explain how you can describe this resultant force and draw and label it. So it's going to be 50 newtons towards the left. You could just draw an arrow with represented 50 newtons, labelled 50 newtons. 15. Objects with different masses are hung on a 10 centimeter spring. The diagram shows how much the spring stretches. The spring is known to obey Hooke's law for masses up to m plus 500 grams, m being the mass, this mass here. So we can to do this question, we can define a few variables. F equals force on the spring, x equals the extension, and c is a constant. Part A. Explain whether there is a linear relationship between the mass and the extension that the spring stretches. Well, yes, F equals kx plus c. The spring obeys this only if c equals 0, which is directly proportional. Which would be a directly proportional spring. So if c equals 0, this term disappears and we get F equals kx, and it would be obeying Hooke's law. B. Explain if there is a direct proportional relationship between the mass and the extension of the spring. F equals kx because the spring obeys Hooke's law, so F is proportional to x. State the difference between a linear relationship and direct proportionality. Linear relationship obeys y equals mx plus c. Direct proportionality obeys y equals mx. So c is 0. What is the mass of the object m? Is 200 grams, because k equals m over x equals 100 divided by 20 minus x, which is the extension, so mass over the extension, which is also equal to m is unknown, divided by 30 minus 10, which is the extension of this spring. So this here, rearrange this for m, and we get 200 grams.